Okay, let's look at these together. Number 1 says, what is the inverse function of each of the following functions? So what is the inverse function of a linear function? That is our first step. What is the inverse function of a linear function? What does it mean to be an inverse of something, of a function? What would we need to do? What does it mean to be an inverse? What was that? Switch? Switch what around? I like that. What would we need to switch around in a function to get the inverse function? Fraction, that's it.
Of the equation.
We would want to switch something around in the equation.
Table.
The table, yeah. Okay, if we had a table, what would we switch?
X and Y.
The x and y. So when we're looking at inverse functions, we want to switch the x and y values. So a linear function, what does a linear function look like as an equation? What's a linear function? It has parentheses. It could have parentheses.
A point. It's a point on a graph.
A point on a graph. What's a linear function? If you saw a linear function and told you to graph it, what would you be looking for? Y equals mx plus b. That's a great linear equation. One of my favorite ones. So I have y equals mx plus b. And we just said we want to switch our x and our y. So if I switch my x and a y, I have x equals m y plus b. Okay, so I switched my x's and my y's, but to be a linear function, what did I need? I needed something alone. Which variable do I want alone?
Y.
The y, exactly. So I want to solve for y now. I have x equals my plus b. My m and my b are just numbers. So what would I need to do to move that b over? Let me rewrite this. I can write a linear equation that would be y equals 4x plus 2. That would be a linear equation with numbers. And it would just look like x equals 4y plus 2. If I want to solve this equation for y, what would I do first? What would I do first to solve for y? I want y to be alone. Subtract. What am I subtracting? I want my y to be alone. I'm going to subtract 2 from both sides. I have x minus 2 equals 4y. I want to keep solving for y. What do I do to solve for y? I want to divide everything by 4. So I can rewrite this all as 1 over 4 times x minus half equals y. So I got y by itself. So first two steps for an inverse function was switch x and y. Second step, solve for y. Now, what does this equation remind us of? We have y by itself. If I asked you to graph that equation, would you know how to graph it? Yeah, why would we know how to graph it? Exactly. Because we have y by itself, it's still in slope-intercept form. It has y on the other side, so it looks a little bit different. But it's still slope-intercept form. And slope-intercept form tells us to graph a line. So when we did our inverse of linear function, I'm going to move all my work off to the side to make it smaller. The inverse of a linear function is still a linear function. I switched x and y, I solved for y, and I still just had a linear function. What does a quadratic function look like? If I gave you an equation, what would you look for to know that's a quadratic? It would have x squared in it. So I could write a quadratic function that's y equals x squared. That is a quadratic function. And I want to find the inverse function of that. So what did we say our first step was? Flip x and y. Exactly. So I could rewrite that as x equals y squared. I just flipped x and y. I switched the places. So x equals y squared. And my next step is to solve for y. How would I get rid of that squared? I have y squared. I could square root it. I would square root both sides. And that would give me square root of x equals y. So I switched my x and y values. I solved for y. And this one I got a square root function. The third function we have, I'm going to move this work a little bit. The third function we have is an exponential function. What does an exponential function look like? What does an exponential function look like? We'd know that we have some number, some base. So y equals a base to the x power. That's our exponential function. And I want to know what the inverse function is. What would I do first? I would switch x and y. I would switch x and y. And that would become x equals 3 to the y. Now, when I see my exponential function, what I think of is our triangle. If I have 3 raised to the power of y, what would I put in my bottom left corner? 3 raised to the power of y. I have 3 raised to the power of y. What goes in my bottom left corner? What's that? Yeah, 3 goes in the bottom right there. And the y goes in the top. I have 3 raised to the power of y. That left side of the triangle is my exponent. And what goes in the bottom right corner? What's on the other side of the equal sign? That's where my x goes. So now, when I see my triangle, what does that make me think of? What does that make me think of? What has our whole unit been about that we've been using the triangle? Log? Yeah, makes me think of logs. My log would go all the way across the bottom. So I switched my x and y values. I solved for y by using my triangle. I would have y equals log base 3 of x. I wrote my log all the way across the bottom. Then what would the inverse function of an exponential function be? What do I see in this answer over here that's different than all the rest? Oh, log, yeah. So the inverse of an exponential function is a logarithmic function. So I'm going to pause there. This idea of inverse functions, and especially the fact that exponential functions and logarithmic functions are inverses, is really important for your test on Thursday. So what questions do we have about our inverse process? Okay. Then I will expect to see a lot of good work with inverses on Thursday. Problem 2 says solve the system by graphing. Okay. Solve the system by graphing. Can we graph that first equation the way it is? Not quite. I'm sure there's a way, but what would make it easier? Getting one variable by itself. Which variable would we want to get by itself? Y. So we have 4x minus 6y equals 12. And Dalen said we want to get y by itself. How would I go about getting y by itself? What would I do first? Subtract 4x from both sides. And now I have negative 6y equals negative 4x plus 12. What else do I need to do to get y by itself? y by itself. Yeah, I'm going to divide everything by -6. And when I simplify that, I have y. Let's keep it in green. I have y equals -4 divided by -6. We'll simplify as 2/3 x. And +12 divided by -6. Give me -2. So I got y by itself. Do I know how to graph it now? Do I graph it now? Yeah, where would I begin? -2, that's my y-intercept. So I'd be at -2. Where would I move from -2? Up to, sorry, that's a 3. Up to and right 3. I have 2/3 x. Oh, looks like that's about as far as I can go in this direction. Can I go the other way? Which way would I move to go the other way? Left 3 and down 2. Right? And I can draw my line. All right. That second equation, y equals 2x plus 2. Do I know how to graph it from there? Yeah, I can graph it right away. I already have my y alone. So where would I start? Where's my y-intercept? +2. And how would I move from there? Up 2, right 1. Okay, it looks like that's about as far as I can go up. What would I do? Left 1, down 2. And I can connect my line there. So now I've graphed both of those equations. How would I solve it? What's my solution? Yeah, it's where they cross, where they intersect. So that looks like it's right about there. So what would my solution be? -3, -4. Exactly. That is how you solve by graphing. We graphed both of them and we looked to see where they intersected. Okay, we are going to talk about number 3 tomorrow.